So here is my DotsandBoxes program. I'll run it. So enter the width of the board. I will create a 2x2 board as an example. Enter the depth of the AI. I'll choose 3 and choose who go first. I choose AI. So AI go first. Its move is 1 0. So it put a line here 1 0. So then it's human's move. So I can go 0 1 0 1. So I put a line here, and AI's move is 3 zeros, it's here, and I can go 1 2. So I put a line here 1 2, and AI's move is 2 1 is here. So AI got this 4 score, and AI's score is 4. And that's the implement of my program. And I have a class of node, and it has a 2D array to represent the box, and the string of player, and the int of row and column, and int of the score of AI and human. And the evaluation is the evaluation function returned as int to evaluate the leaves of the tree. And apply is the depth of the node, and the node of parents, and the node of child, storing a linked list. And this constructor, so we create a board. In this function, I put the even row and even columns, and put a random integer as score. So here's the random integer 1 to 5 as the score, and add the child to the children list. And this leaves is I traverse all the possible leaves node of the game tree in DFS order and add the children list. So if this place is empty, so it's possible nodes, we add the child. And move is update the lines, row and columns, and update the score, and change the player. There's a heuristic function, which is score of AI minus score of human, and change score. So if we check the complete first, check complete is to check the box 4 side. This 4 side already has a line, so the inside this box score can be updated to whatever human player or AI player. And check empty is to check if this box has an empty place. So this means has an empty place, so it can return false, it can draw a line. And to print the board, there's an example to 2x2 board, because we need a place to represent the dots and lines, so it's actually 5x5 columns. And the minimax algorithm. In this algorithm, I use the minimax to get the utility value and use alpha beta proofing to prompt the unnecessary leaves. So here I search through all the leaves and get every child of the game tree. And if the root node is AI, which is max node, so we need to get max. And so I start as the negative infinity because it only can increase. So for all the children of the leaves, I use a recursion to recursively use this algorithm to update the value of the alpha and beta. And I use alpha and beta to prune the unnecessary leaf node. So first I update the max value and update the alpha value as max. So alpha is the max value found so far in the max node. So if beta is the min value found so far. So if beta less or equals to than alpha, I stop generate the other leaf node because alpha is already the max value found so far, and beta is means found so far in max parents min node. So whatever the beta value is, it cannot larger than the alpha value, and so is the same in the min. We already find the min value in the beta, so whatever the alpha value larger than beta, it will not change this min value. So we use this min max algorithm to get the unity, and in the main function to here. If if this is AI's move, I use this min max move to make a move.